Hey everyone, and welcome. Today, we're going to break down a concept that's like at the very heart of all scientific discovery, control groups and experimental groups. And trust me, this isn't just some boring textbook stuff. This is how we figure out what's a proven fact and what's just fiction. I mean, really think about it. You've got a brand new fertilizer or a new drug, maybe even a new way of teaching. How on earth do you prove it's actually working and not just, a coincidence? How do you separate a real cause and effect from just random chance? That's the big question we're tackling. Well, the answer comes down to one simple idea: creating a fair test. Because to know if your big new idea is the real deal, you absolutely need something to measure it against. You need a benchmark, a baseline. Without that comparison, you're basically just guessing in the dark. And that's where the idea of control comes in. It's so powerful. A control is that baseline. It's the standard, the thing that doesn't change, which lets us see the true impact of the one thing we're trying to test. Without it, any results you get are pretty much meaningless. So in every properly designed experiment, you've basically got two main characters, the real stars of the show. And once you understand their roles, the whole process just clicks into place. First up, let's talk about the control group. You can think of this as the business as usual team. They're the ones who don't get the new thing being tested. They just keep on doing what they've always done. And that gives us that crucial baseline we've been talking about. They are our essential point of reference. And then on the other side, you have the experimental group. Now this is where all the action happens. This is the group that actually gets the new thing, the new variable, the treatment, the one thing we're actually curious about. They are the ones who are experiencing the change. This table right here shows that comparison perfectly. Let's use that classic fertilizer example. In the control group, you've got plants getting regular old soil and water, nothing new. But the experimental group, they get the exact same conditions plus the fertilizer. And that one single difference is what lets us measure the real effect. Okay, so you've met the main players, but how do you actually spot them out in the wild, in any experiment you read about? Well, I'm about to give you a super simple game plan, a 4-step method that, honestly, works every single time. Let's walk through this together. Step 1, just find the one thing being tested. Ask yourself, what's the one thing that's different? That's your variable. Step 2, now find the group that doesn't get that change. And boom, that's your control group. Step 3, find the group that does get the change. You've got it. That's your experimental group. And finally, step 4, the big payoff. You compare the results. Any difference you see between the two groups? That's the effect of your variable. Simple, right? Okay, theory is one thing, but let's put this into practice. We're going to use a really simple, real-world example that I'm pretty sure you can relate to. So here's the scenario. A scientist wants to find out for sure if caffeine actually makes your heart beat faster. It's a simple question, right? But to get a real, reliable answer, you need that fair test we were talking about. Okay, so looking at this slide, let's use our 4 steps. What's the variable? Caffeine, of course. Who gets it? The experimental group, the ones drinking coffee. And who doesn't get it? The control group, who are just drinking plain water. And notice, everything else, like how much they drink or when they drink it, is kept exactly the same for both groups. That's key. So after a bit, the scientist checks everyone's heart rate. And if the rate has only gone up for the coffee drinkers, well, you have a crystal clear answer. The control group proves the effect wasn't just caused by drinking something, it was specifically the caffeine. That's the power of comparison. All right, I think you're really getting the hang of this. But, like with any new skill, there are a few common pitfalls that can easily trip you up. So let's go over a couple of them so you can sidestep them like a pro. It is so easy to get these ideas tangled up if you're not paying close attention. So let's shine a light on the most common mistakes people make so you can spot them and, more importantly, avoid them. Okay, the biggest mistake by far is thinking both groups get the exact same treatment. The whole point is that they don't. Another classic is just forgetting that the control group is your no-change baseline. And finally, a tricky one. Don't mix up the thing you're changing, the independent variable, with the result you're measuring. So here are a few quick tips to make this all stick in your brain. Just remember this. Control means normal condition, no change. Experimental means something new is being changed or tested. And always remember, the one key difference between the two groups is that single, independent variable. That's it. In fact, if you forget everything else we talked about today, please just remember what's on this next slide.
I'm going to boil it all down to one simple, powerful formula for success.
And here it is, the core logic in just 3 lines. The control group gives you your baseline. That's your no change. The experimental group gets the one thing you're testing. That's the change. And when you compare their results, you find the effect. If you can master that simple flow, you've mastered the heart of experimental science. Pretty cool, huh?